Hey everybody, it is Mr. Ensminger here with another video about arrays in C++. As you can see at the top, I have a, if you want to call it a header. I want to remind you that these are not just passive sit back and watch kind of videos. You should be doing the coding along with me during those videos. If you're not, you really should be. You're missing out on a great deal of content. That just watching the videos is not going to do enough. You really should be coding these along with me. That's why they're only about 10-15 minutes long. The other time, you can spend pausing and coding them yourselves or finding your own mistakes. So just want to kind of throw that out there. We've been talking about arrays, and so in this program, continuing the theme of the applications, I have a couple of other applications we can do here. For the first problem, I'm going to count the number of positive, negatives, and zeros. We're going to generate a random number sequence filled into an array. The second one, I'm going to, in that array, then find the smallest and the largest number. And then finally, I'm going to find what's called the Olympic average. It's also sometimes called the centered average, to do the best job they can of getting rid of bias in Olympic sports that are judged. What they do is they will drop the highest and lowest score. That way, if there's a biased judge, they can just disregard those. And then once you do that, you will find the average of the dropped numbers, or the average of the remaining numbers, not the dropped numbers. So let's begin. Much like we did in our last video, we're going to put in not just IOStream, but also the standard library, as well as time. That's going to help us with our random numbers. Our main function, srand times 0, that'll let us do our random number generator. And we haven't done arrays with functions yet. We will, but everything we're doing here is going to be inside the main program. So I will create an array of size, let's make it kind of large this time, of size 20 numbers. And I'm going to fill it with random numbers from -10 to 10. Okay? So, int nums 20. Okay, so that's declaring and saying the size of the array. As you saw in class and the previous video, the array currently is empty. There's not just 0 inside of it, but there's nothing. So we don't want to access anything yet until we now fill the array. So I guess I technically should split these comments. Let me just be a little bit more accurate here. So create the array and then fill the array with negative numbers. Numbers from -10 to 10. I can't talk tonight. For int, use a loop variable. I, n, x, doesn't really matter. We'll go from 0 up to, but don't include 20. As you've hopefully learned by now, in our arrays in C++, they begin with element 0. The first index is 0, and an array of size 20 goes 0 to 19. There is no 20. From here, if I say num x, so I go through the for loop 0 up to 19, really, and then I'm going to do a rand mod, and keep in mind the number after the mod is the range of numbers. It is the highest minus the lowest plus 1. The range of numbers from 10 to -10 is actually 21 numbers. 10 minus -10 is 20, add 1 is 21. The lowest number is plus -10, or of course you can just do -10. So that will give you the numbers from -10 to 10 randomly. And it would obviously help if we also printed those, so fill it with random numbers and print. So I'm just going to do that all at once because why not? Go in here, cout x, which is the location, and then num, x, and num. Okay, so let's just hold there for a minute. Oh, I forgot my using namespace. You're probably watching this video at home screaming at it saying, you forgot your using namespace. Well, oops, you're right. Alright, so let's just take a look and see what that gives us quick. There we go. nice little series of numbers, a couple tens, definitely some negatives in there. I don't see any zeros yet, but it is random, so let's just give it another little spin. There's a 0, so it seems like I verified that all numbers are represented. There's some tens in there, so there's some negatives, there's some zeros. I haven't seen negative 10 yet, but I think you can trust me, it's in there somewhere. It could be in there somewhere. So the first problem is to count the positives, negatives, and zeros. And so that's exactly what I'm going to do. I have my array. Let me also create counts. Pos count, 0. Neg count, and 0 count. Initialize them all to zeros. Seems fair. Now, declare and initialize our counters. Okay, so we did that. And so, now when we generate, we print, somewhere in here, it doesn't really matter where, as long as it's after we generate the numbers, we can now determine the accurate counts. So if I come in here and I say, if the number that I just picked, numx, is less than 0, then I have one more negative. Else if the numx is greater than 0, then pos counts, plus plus. Else you have a 0, so 0 count, plus 1. So greater than 0, less than 0, I guess, less than 0, greater than 0, and then equal to 0. Of course, we don't want to print out how many we have until everything is generated. So, after the loop ends, now print the counts. So, cout positives equals pos count, and L. Negatives equals neg counts, and L. And finally, zeros equals 0 counts, and L. So that should take care of the first part of our program. Let's go ahead and try it out. It tells me I have 10, 8, and 2. So let's just go through. Let's make sure we have 2 zeros. There's 1, 2. Looks accurate. Let's count the negatives. We have 1, 2, 3, 4, 5, 6, 7, 8. And of course, because there's 20 numbers, take away 2 and 8 from 20, and you're left with 10. So our counts seem accurate. So that's one way we can apply what we're doing with arrays. We do oftentimes the random numbers simply because that way we don't have to sit here and type in our own numbers. But of course we could just replace that line with a cin. We could say cin numx, and we could just enter all 20 numbers. But again, that's tedious because I have to sit there and type in 20 numbers. But could happen. So next, find the smallest and largest numbers, which of course we need for the third program. I shouldn't say the third program because it's all one program. The third part of the same program. So to do the second part of the program, we're going to find the smallest and largest. Okay. So I'm going to come down here, and we've done a program like this before. But we haven't done it with arrays. So the smallest number, you want to initialize this to a number that is larger than any possible smallest number, because really what's potentially the smallest number in this list? It's negative 10. So I know this is extremely improbable. What if all 20 of your numbers are 10? Well, then your largest and your smallest are both 10. So because of that, the biggest possible smallest number is going to be 10. Until I prove that otherwise, I'm just going to say the smallest is 10. The largest, using the same logic but in reverse, what is the smallest possible largest number? It's negative 10 for the same reasons. So I initialize them to the opposite of what they really truly would be. Now, I don't really have to do 10. I can do anything above 10. I can do 11. I can do the integer min, integer max. Because the if statements are going to determine the outcome anyway. But I need to initialize them. You can't just let them, declare them or set them equal to 0. Like, you have to give them starting values, and starting values have to make sense. So we generated, we printed, we counted. What I'm going to do next is say if the number that you just generated, numx, is bigger than the former biggest. So if the number is bigger than the largest, it's your new largest. Now remember, we store these from right to left, so if the number is bigger than the biggest, that means the number stores into the largest, and vice versa. If the number is smaller than the smallest, then the smallest equals the number we just got. So we're doing it on the fly. We're not waiting till the whole list is done to determine this. It's really not that dissimilar from the program we did before, where you typed in numbers and you didn't have to really keep track of them. Now, when we do the third part of the program, this will matter, but again, for right now, we have the largest and smallest. So after the loop ends, now print the counts, and the smallest and largest, so cout, smallest equals smallest, and now cout largest equals largest, and out. Let's give it a try, see if it works. Now, of course, often it's going to tell me -10, 10, and sure enough, that's what it did, because in my program there's a -10 and there's a 10. So that's going to happen a lot, but let's just try it again. Ooh, now the smallest is -9 because there was no -10 in here. So if we keep trying it, it does give us accurate results. -9 and 10, -7 and 10. 10 just wants to seem to keep coming up. There we go. Largest is 9 now. So like I said, it sure seems like it works. So as step 1 and 2. Step 3 then, can we find the Olympic average? Can we take and find the average of not 20 numbers but 18 numbers after we've dropped off the highest and lowest? Well, of course we can. Here's how I'm going to do it. Go back and add all of the numbers in the array. Okay, so stay with me here. I'm also going to declare a total variable, total equals 0, for int n, x, I, whatever, 0, x goes up to 20, x plus, total equals total plus num x. So that'll give me all 20 numbers. But what do I want to take out? I want to take out the smallest and largest. Now, if there are duplicates, like let's say there's 3 10s, I only want to take out one of them, which is why I had to do this after the fact. Okay, so if you're thinking, well, why didn't we just do it back in the original program? The thing is, like as you're generating the sequence, you don't know what's yet to come. So if you have 9, like 9 might be the largest number at that point, but later on in the list you might get 10. So you can't really do the math ahead of time. You have to wait till the whole thing's done and then go back and determine this. The other thing you do not want to do would be to say, oh, go through, but then do an if statement saying, don't add the smallest and largest to the total. The reason you have to be careful with that is because what if there's multiple 10s? What if there's multiple -10s? You don't want to take out all of them, just one of them. So what I'm going to do is add up all of them, but then say total equals total and take away one smallest, one largest, and then your average. The centered average is, and then you're going to say total divided by not 20, but 18. Not just 18, but 18.0, because you've taken out those two numbers. So let's give it a try. Here we go. Of course, probability-wise, what's the average always going to be about? It's going to be about 0, most likely, because you have an equal number of numbers above 10 as you do below 10. So, if I run this a couple times, my guess is that I'm probably pretty often going to get a decimal somewhere around 0. Now, because there's not that many numbers, you could have something a little bit off. It seems like there's more negatives than there are positives this time, So it makes sense, like, yeah, there probably is going to be a negative average. But there we go. That is a neat little program. One thing I will mention, in C++, if I haven't mentioned already, in C++, arrays don't know their own length, which can cause you to use a lot of what are called magic numbers in your code. Like, this program's not really easily expandable because in my program I have multiple 20, 20, down here's a 20, and then the 18 is based off of 20. If I ever wanted to do more numbers or fewer numbers, like let's say I want to do 100 numbers, the unfortunate thing is that I would have to change all of those. But I don't actually have to. The last thing I want to show you today is in C++, no, you cannot make that a variable. You can't make a resizable array. However, you can make it a constant variable. If I say const int size equals 20, by convention, by naming convention, constants are in all caps. That sets them apart. A constant is a variable that you can't change. If I try on the next line to say size is now equal to 10, it's going to yell at me because I'm trying to modify something that's constant. Now, here's why this matters. I can't just make any old variable here. Like, I can't see in that size. But if there's a variable in my program that's constant, I can do this. I can say size, which down here, size. Remember, these are not based off of the size. These are just negative 10 to 10. And then down here, size. Then down here, size minus 2, which is a integer. So make sure we typecast it also, because you're going to do integer draw by integer otherwise. So just keep that in mind. Doing it as a constant variable will allow you to make easier changes down the road. And I know that's sometimes difficult to do because you just want to get the program done, but it's something that we'll use going forward. So thanks a lot for watching. Take care, and best of luck coding the program.